Hello future professionals, welcome to day 30 of our top 100 coding question analysis. Today we are challenged with a question to find the LCM and GCD of two given numbers. Now that we have our problem statement defined, let's have a hands-on experience. Before we solve this question, we must have two basic concepts. That is, first would be the methodology to solve the problem. There are two methodologies. One is through prime factorization and other is through Euclidean division lemma. Theory, right? The second would be the relationship between the numbers and HCF LCM, right? When these two concepts are clear, we will be able to find the LCM and GCD of the numbers, right? As said, there are two methods to find the HCF and LCM, but we will be implementing the Euclidean division lemma theory in today's program. Let's now look at what is Euclidean division lemma theory states, right? The theory states that for any two integers a, b, there exist two other integers q and r where all these four are in such a relation that a is equal to q into b plus r, right? If you are not able to grasp this equation, relate this with this equation, that is dividend equal to quotient into divisor plus remainder, right? Now what are the conditions here that are constraints? Constraints are remainder can be greater than or equal to 0 but less than divisor, right? And the divisor can be less than or equal to the dividend but must be greater than 0, right? The same two constraints apply here as well. R must be greater than or equal to 0 but must be less than b, right? Then b must be less than or equal to a but greater than 0, right? Now that we have understood what is Euclidean division lemma, theory, let's apply it to find the HCF of two numbers. Let's say we are given a question to find HCF of 24 and 256, right? The bigger number, the maximum number among this will become dividend, that is 256, and the minimum number becomes the divisor, that is 24, right? Let's start dividing. 256, so let's divide, becomes 24, we get the remainder 1, then 6 comes down, then 16 is not divisible by 24, so the remainder, the new remainder becomes the divisor and the old divisor becomes the new dividend, right? Now we'll divide, we get 16 and we get the remainder as 8. Now 16 cannot divide 8, so we make the old divisor the new dividend and the new remainder as the divisor, right? We divide and we get 0, right? Now remainder is 0. So the HCF of two numbers would be the latest divisor. Latest divisor is HCF, right? So HCF of 24 256 is 8, right? Now the second concept is that find LCM. The relation between A, B and their HCF and LCM is that A into B equal to HCF into LCM, right? This is a fact, right? So now we know that A, B and HCF, we shall find LCM as A star B by HCF. What is A? It is 24. What is B? It is 256. What is HCF? 8. So we cancel. We get the result as 768. The LCM of 24, 256 is 768, right? And the HCF of 24, 256 is 8, right? Now that we have derived the HCF and LCM of two numbers, let's derive the logic out of the solved example. The logic is that first we get both the numbers A and B from the user. Second, we use Euclidean division lemma theory to get HCF of AB. Here we make few observations. The observations are the maximum of A, B becomes dividend and minimum of A, B becomes divisor, right? Then after each step, that is after each division, the new dividend becomes the current divisor and the new divisor becomes the remainder when the dividend is divided by the current divisor, that is nothing but the remainder, as we use percentage, right? Now we continue until the divisor is not equal to 0, right? This will be the condition. Let's say do while, right? Next, third step would be, now the loop has been terminated, so we would have found our HCF. We assign HCF value as the dividend, right? Next, fourth step is that we calculate HCM by using the relationship formula, that is A by B by HCF gives us LCM. Then we print HCF and LCM of AB. Then we terminate the program. Right. Now that we have looked at the logic, let's put it into practice by coding our program. First, we define a function to get the user's input. I name the function getUserInput. Here, we get both the numbers a and b from the user. Then, we return both a and b. Next, we define a function to find the HCF and LCM of both a and b. It gets the parameters a and b. Right? Now, we find the maximum of two numbers. If a is greater than b, then dividend becomes a, then divisor becomes b. Else, if b is greater than a, then dividend becomes b and the divisor becomes a. Right? Next, while the divisor is not equal to 0, right? Then we store the current divisor value in a temporary variable and calculate the remainder of the division, right? And store the value in the divisor. Now the new divisor is assigned the remainder value. Next, the new dividend will contain the value of the current divisor, right? Now this will happen until divisor is not equal to 0. Next, we assign the value of HCF as dividend. Then we print the HCF. Next, we calculate the LCM by using the relationship formula where A into B divided by the HCF. Right, we can change this to HCF. Then we get our LCM. Right, after we get our LCM, we print our LCM. Now that we have defined both our functions, it's time we call our functions. I call the getUserInput function and store the return value in AB respectively. Next, I call the HCF and LCM function and pass A and B as the argument. As we do not have any errors or warning signals, let's run the program. The program asks me the number A. Let me input 24. It is asking me the value of the second number. Let me input 256. The program tells me the HCF is 8 and the LCM is 768. Right. Thus, we have successfully completed our program. I hope you would have got the best out of this video. I recommend you subscribing our channel to get more such interesting videos. I also recommend you to like and share the videos if you find it supportive and interesting.